Good morning, champions, and happy Thursday. Today we're going to talk about perfect squares and perfect cubes. I know you're going to do a great job, and so does Mr. Smiles. Let's dive right into our video. Start by writing, I'm going to show you how great I am on the line. Today is your chance, again, to show how great you are in math class. Now that we've written down our credo, let's start with some problems. First, find the base height and area of the first parallelogram. What's the base? The base of this parallelogram is 10 inches. What's the height? The height is 5 inches. It's at a right angle to the base. I don't use 6 because it's on a diagonal line. If the base is 10 and the height is 5, what's the area? Well, 10 times 5 is 50 inches squared. Now let's look at one more. Find the base, height, and area of this parallelogram. Go ahead and do that now. The base is 15. The height is 5 because it makes a right angle with the base. 15 times 5 is 75 centimeters squared. Now find the base, height, and area of each triangle. Let's start with the triangle on the left. Make sure you're writing everything down on your paper as we go over it on the screen. First, what's the base of the triangle on the left? The base is 21. What's the height of the triangle on the left? Well, the height is 8. 8 makes a right angle with 21. Now I can multiply 21 times 8. What's 21 times 8? Well, 1 times 8 is 8. 8 times 2 is 16. To find the area of a triangle, I still need to divide by 2, because a triangle is half of a parallelogram. So I can write 168 divided by 2. When I divide 168 divided by 2, do I start the division with 100, 16 tens, or 168 ones? I start with 16 tens. How many times does 2 go into 16? 2 goes into 16 8 times. 8 times 2 is 16. When I subtract, I have 0 left over. Bring down my 8. How many times does 2 go into 8? 2 goes into 8 4 times. 4 times 2 is 8. When I subtract, I have 0 left over. So the area is 84 square units. Now you try one. What's the base, height, and area of the triangle on the right? The base is 14. The height is 5 because 5 is at a right angle to the base. When I multiply 14 times 5, I get 70. Then I can divide by 2 to find that the area is 35 square units. Now let's find the area of some quadrilaterals. To find the area of the first quadrilateral, I can split it into two triangles. Go ahead and split your work into two triangles as well. What's the base of the top triangle? The base of the top triangle is 1, 2, 3, 4, 5, 6. What's the height of the top triangle? The height of the top triangle is 1, 2. So what's the area of the top triangle? Well, 6 times 2 is 12. 12 divided by 2 is 6. So the area of the top triangle is 6. What's the base of the bottom triangle? The base of the bottom triangle is also 6. What's the height of the bottom triangle? The height of the bottom triangle is 1, 2, 3, 4. So what's the area of the bottom triangle? Well, 6 times 4 is 24. 24 divided by 2 is 12. The area of the bottom triangle is 12. Now I can add my two areas to find the total area of the shape. What's 12 plus 6? It's 18 square units. Now you find the area of the next shape. I can cut it into a triangle, a rectangle, and another triangle. Go ahead and find that area now. The area of the figure is 16 square units. The top triangle has an area of 2, the middle rectangle has an area of 4, and the bottom triangle has an area of 10. Now let's find the surface area of two different shapes. Remember, to find the surface area, I need to find the total area when I add up all the faces. So let's look at the first shape. First, let's find the dimensions. The length is 2. The width is 1, 2, 3, 4, 5. And the height is 1, 2, 3. Now I can find the area of each face. First, let's do the front face. I can see that the base is 5 and the height is 3. What's the area? Well, 3 times 5 is 15. The back face would also have an area of 15 because the two faces are equal. Now let's look at the side face. I can see that the base is 2 and the height is 3. What's the area? Well, 2 times 3 is 6. Each side would have a face with an area of 6. Now let's look at the top face. I can see that the base is 1, 2, 3, 4, 5, and the height is 2. What's the area? Well, 2 times 5 is 10. If the top face has an area of 10, the bottom face also has an area of 10. I can add all those areas to find the total surface area. What do you get when you add 15, 15, 6, 6, 10, and 10? The surface area is 62 square units. Now you find the surface area of the next shape. Go ahead and do that now. The area of the front face can be found by multiplying 3 times 2. That's 6. So the back face is also 6. The area of the side face can be found by multiplying 3 times 2. That's also 6. So the other side is also 6. The area of the top and bottom can be found by multiplying 3 times 3. That's 9. When I add up 6 plus 6 plus 6 plus 6 plus 9 plus 9, I get a surface area of 42 square units. Now let's dive into today's lesson. Today we're going to talk about perfect squares and perfect cubes. Let's start with perfect squares. 9 is a perfect square because 9 small squares can be arranged to make a larger square. Go ahead and write perfect square in the first blank. To make a larger square with a side length of 3, because 3 times itself is 9. The area of the square is 9. 10 is not a perfect square because 10 small squares can't be arranged to make a square. You can see some different ways to arrange 10 small squares over here. So a number is a perfect square if another number can be multiplied times itself. 1, 2, 3 times 1, 2, 3 would give me 9. So let's identify some other perfect squares. Is 15 a perfect square? Can a number be multiplied by itself to make 15? No, 15 is not a perfect square. Is 16 a perfect square? Yes, 4 times 4 is 16. So 16 is a perfect square. Is 24 a perfect square? No, there's no number that can be multiplied times itself to make 24. Is 25 a perfect square? Yes, 25 is a perfect square because 5 multiplied by itself is 25. Is 32 a perfect square? No. There's no number that can be multiplied by itself to make 32. Is 36 a perfect square? Yes. 6 times 6 is 36. Now prove that 4 is a perfect square by drawing a square with 4 square units on the grid. Go ahead and do that now. When I draw a perfect square with an area of 4, what's the length of each side? The length of each side is 2 units. Now let's apply what we've learned about perfect squares. A square has a side length of 7 kilometers. What's its area? Well, I would multiply base times height, 7 times 7. Its area is 49. The area of a square is 64 square kilometers. What's the length of the side? What number times itself equals 64? It's 8. 8 times 8 is 64. A square has a side length of 5 centimeters. What's the area? Well, 5 times 5 is 25. A square has an area of 36 square centimeters. What's the side length? It's 6, because 6 times 6 is 36. We also might have perfect cubes. The number 27 is a perfect cube. It has a length, width, and height of 3. The volume would be 27 because 3 times 3 times 3 is 27. What would be the volume of a cube with side length 4? That would mean the length, width, and height are all 4. So I would do 4 times 4. That's 16. 16 times 4 is 64. So the volume would be 64 cubic units. Now you try a few. What would be the volume of a cube that has side length 5? Well, 5 times 5 is 25. 25 times 5 is 125 cubic units. What would be the volume of a cube with a side length of 6? Or 6 times 6 times 6? The volume would be 216 cubic units. What about if a cube had a side length of 7? The volume would be 343 cubic units. Last year, we used exponents to represent powers of 10. So, what is the area of a square with side length of 4? Well, what would a multiplication sentence be? It would be 4 times 4, length times width. To write that as an exponent, I would write 4 to the second power. 4 multiplied by itself twice, with 2 4's being multiplied. 4 times 4 is 16. What is the area of a square with side length 5? How would I write that as a multiplication sentence? I would write 5 times 5. How would I write that as an exponent? I would write it as 5 to the second power, 2 5's being multiplied together. In standard form, that's 25. What is the volume of a cube with edge length 4? I would write that as 4 times 4 times 4. How would I write that as an exponent? Well, 4 being multiplied 3 times, or 4 to the third power. 4 times 4 is 16, times 4 is 64. What about the volume of a cube with edge length 7? Well, I would write that as 7 times 7 times 7. How would I write that as an exponent? That's 7 to the third power. 7 to the third power is 343. When we raise a number to the second power, we call that squared, because the area of a square with a side length of that number is that number to the second power. When we raise a number to the third power, we call it cubed, because the volume of a cube with side length of that number is that number raised to the third power. Squared means to the second power, cubed means to the third power. Now try two last problems. Which is bigger, 5 squared or 3 cubed? 3 cubed is bigger. 3 times 3 is 9, and 9 times 3 is 27. 5 times 5 is 25. So 3 cubed, 27, is larger than 5 squared, 25. Now you try another. Which is bigger, 4 to the third power or 7 squared? 4 to the third power is 64, so it's larger. You've done a great job on this video. Now go to IXL Practice FF2 or FF15.